In today's lesson, we are going to be looking at angles and triangles and quadrilaterals. Some of this might be review for you, and some of this might be new, depending on what you looked at in grade 8. We're going to look at a couple examples and just some properties of angles and triangles and quadrilaterals. So the first thing we wanted to do is determine the measures of angle x and angle y. So we see the two angles here, angle x, angle y. The first one I'm going to solve for is angle x. And the reason being is that it exists inside this triangle, and I have the two other angles. Right? And there is a property, right? This is one of the more common ones, so you probably do know that the sum of the angles inside a triangle adds up to 180 degrees. Right? So I can do angle x is going to equal 180 minus 43 minus 78. And I get angle x is equal to 59 degrees. Right, so this property is going to write off to the side all angles in a triangle add to 180. Right, so if you don't remember that, or if you didn't know that, I would suggest writing it down just so that you're aware moving forward. The next angle, angle y, I'm going to solve for this. And another property that we may know of is that these two angles, angle x and angle y, they form together to make a straight line. Right, so these two angles here add together to form a straight line. And a straight line has a sum of 180 degrees. So again, similar to the last one example that we did, we can do the same thing here, except we're going to do 180 minus 59. So angle y is equal to 121 degrees. And again, the property here, straight line equals 180 degrees. Right, so again, just some things that you might want to remember if you didn't already. Now, looking at this triangle, do we notice anything else? Do we notice any other properties? Well, we might notice that this angle here, 121, is equal to the sum of 43 and 78. Right, so this is another property that can exist in triangles. Oops, let me clear this up a bit. In this property, the sum of an exterior angle is equal to, or sorry, not the sum, right? An exterior angle is equal to the sum of opposite interior angles. So a little bit longer of a property, but again, another one that you might come across. So that's just basically saying the 43 and the 78 add up to 121. That's this exterior angle is equal to the sum of these two angles together. Looking at another example, right? We want you to again determine the measures of x and y. Right, so we see x and y. We're going to have to come up with some other information before I can find those two. So first, if I know that this angle here is 117, and this other angle in here has to be 180 minus 117, 180 minus 117, 63 degrees. So I know this angle is 63 degrees. If this angle is a right angle, then this angle has to be a right angle as well, because they both have to add up to 180 degrees. Now I can find angle y. Angle y is going to equal 180 minus 63 minus 90. And we get 27 degrees. So angle y is 27 degrees. If that's the case, then again, these two angles, x and y, form to make a straight line. So angle x is going to equal 180 minus 27, and angle x is going to equal 153 degrees. Now, do we notice anything about the exterior angles? So this is an example where we're given the exterior angles of a triangle. Right, so all the exterior angles are given. Do we notice anything about them? And if we take a look at them, 117, 153, 90, we should see that they add up to 180 degrees, or sorry, 360 degrees. So 117 plus 153 plus 90 equals 360 degrees. Right, so that's a property of triangles as well, and that is the sum of exterior angles is 360 degrees. Right, so we could have gone through and did 360 minus 117 minus 90 and got our answer of 153. Or we could use the straight line idea to figure out the interior angles of this triangle and then find y and then find x. So different ways you can go about solving these types of questions. Example 2, we want to determine the measures of the interior angles of the triangle. Except I'm not given any angles, I'm given expressions. But what we can do is we can take these expressions using our knowledge or theorems or kind of properties. We can help combine the two to basically help solve for these interior angles. Right, so we know that all three interior angles of a triangle have to add up to 180 degrees. So let's go through and add those up. So 5x plus 1 plus my next angle plus my next angle of 10x plus 3 plus my next angle of 7x has to equal 180 degrees. Now, we've dealt with expressions like this before, right? Or equations like this before. And the first step is to collect like terms. So I'm going to collect like terms. I'm going to go through and add up all my like terms. So I'm going to highlight the like terms just for reference. So I have all my x's, and then I have just my number terms. So 5x plus 10x plus 7x gives me 22x. 1 plus 3, it gives me 4. So I get 22x plus 4 equals 180. Now this is a two-step equation. I'm going to subtract 4 from both sides, deal with the separate variable first. One side will cancel out. We get 22x equals 180. Now we're going to divide by 22. And we get x is equal to 8. Now that's not just our interior angle. That's what x equals. So the next step that we have to do is we have to go through now and plug x into each expression and determine what our interior angles are. Let's just move all of this over. now we're going to focus on our interior angles. So the first one, 5x plus 1. We had 5 times 8 now, plus 1 equals 41 degrees. So I know that this one is 41 degrees. The next one, 10x plus 3, 10 times 8 plus 3, or 83 degrees. And the third one, if I really wanted to, I could just go and subtract the two other angles from 180. Or again, I can just plug it in. So 7 times x, or 7 times 8, equals 56 degrees. So by kind of combining my understanding of solving equations and substitution, I can find, and with my angle properties, I could find the interior angles of this triangle. We're going to move on to quadrilaterals, and this is going to be very similar to what we just looked at in triangles, just some differences. So the first thing we want to do is determine the measures of angle x. Basically, we want to figure out what does angle x equal. And there is a property, if we didn't know it, that sum of interior angles of a quadrilateral equals 360 degrees. So if we're dealing with a quadrilateral or a four-sided figure, the sum of the interior angles adds up to 360 degrees. So using that, we can now figure out our unknown value x. So in this case, angle x is going to equal 360 minus 134 minus 46 minus 59. Angle x is equal to 121 degrees. So again, nothing too complicated with this one, just a little bit more straightforward, similar to our triangle one. Here, we're going to determine the measures of angle x. Now, there is a short way, but let's go through a longer way and kind of learn a property as we go. So we can see that these exterior angles form straight lines with all of our interior angles. And we're going to use that property to help us then determine work our way to what x is. So let's find our interior angle here. So 180 minus 121 equals 59. So this is 59 degrees. If I look at this angle here, 180 minus 65 equals 115. This angle here, we don't know yet. Let's move down here. This angle is 180 minus 140, 40 degrees. Now I can find this unknown angle inside our quadrilateral because I can do 360 minus 115 minus 59 minus 40. And get 146. So I can find all the angles inside my quadrilateral, and now that I know that this one is 146, now I can go and find angle x, because angle x is going to equal 180 minus 146, which gives me 34 degrees. So angle x is 34 degrees. Now, we could go through and do that. There's no problem with what we just did. It was a little bit tedious that we had to find 4 other angles first before we could find the angle that we wanted. Now, let's take a look at all of our exterior angles again. And what do we notice? Well, if we look at our exterior angles, we have 59, we have 115, we have, not 115, sorry. We have 59, we have 65, we have 34, and we have 140. What do we notice about all three or all of those angles? Well, let's go through and add them up. 59 plus 65 plus 34 plus 140. Oh, not 65, my mistake. Oh yeah, 65. Sorry, added up the wrong one. 121. 121, 65, 34, 140. We see that they all add up to 360 degrees. So similar to the triangle, right, the triangle that we looked at before, the sum of exterior angles equals 360 degrees. And you're going to find that this property is true for every type of polygon. Right? So any sided figure, the sum of exterior angles is always going to add up to 360 degrees. Even if it's a 10-sided figure or a 15-sided figure or a 20-sided figure, the exterior angles are always going to add up to 360 degrees. Right? So we could have just looked at all the exterior angles and then 360 minus 121 minus 65 minus 140 and got our answer as well. But again, if we don't remember that property, there are multiple ways that we can sometimes get to our answer. Our next example, or our final example, is very similar to the triangle one that we looked at, except now we're dealing with a quadrilateral. Right? So it's going to be the same idea. We're going to add up all of our sides. So let's start with our side, so not all of our sides, all of our angles. Right, so 5x plus 3 plus 9x plus 11 plus 10x plus 8 plus 4x plus 2 has to equal 360 degrees. Because it's a quadrilateral, it's a four-sided figure, so all those angles have to add up to 360 degrees. First, I'm going to collect all my like terms. So the x's, and then all the constants, or just the values. So 5x and 9x, 10x, and 4x gives me 28x. 3 plus 11 plus 8 plus 2 gives me 24. So 28x plus 24 equals 360. I'm going to subtract 24 from both sides. One side will cancel out. Right, so just solving a two-step equation, 28x equals 336. Divide both sides by 28. Again, one side cancels out. Left with x is equal to 12. Again, this isn't the angle, right? This is just what x equals. But now what I can do is I can go back and I can plug in x, or 12 for x, for each of my angles and determine what the actual interior angle is. So for my interior angles, the first one, so 5x plus 3 becomes 5 times 12 plus 3. Or 63 degrees. The next one, 9x plus 11 becomes 9 times 12 plus 11. We get 119 degrees. 10x plus 8 equals 10 times 12 plus 8 equals 128 degrees. And lastly, again, if we wanted to, we could just do 360 minus the 3 angles we just found, or let's just plug it into our expression for that angle. So 4x plus 2 equals 4 times 12 plus 2 equals 50 degrees. So that is the measure of each interior angle. So very similar to what we did with the triangle, right? We're kind of, again, combining, collecting like terms, solving equations with our angle properties. Right, so looking back, we do have some angle properties just to kind of remember, right? The sum of exterior angles equals 360 degrees. That's true for any type of polygon. The sum of interior angles of a quadrilateral is 360. That one you may have already known. Again, sum of exterior angles is 360. An exterior angle is equal to the sum of opposite interior angles. All angles in a triangle add to 180, and a straight line equals 180 degrees. Right? There are other properties that you may know of, but again, these are some of the main ones that we're going to be looking at and using.